I had indicated, so welcome back from lunch, folks. It's good to see you. I had indicated before lunch, I should say prior to lunch, that I would go through a little example of intergenerational transmission of propensity. Like so much of this, I'm winging it a little bit. This is not according to script. So I think we'll try one approach here, and we'll use that to explore a mechanism I think is quite convenient as well as quite general in terms of this. Okay, so the question posed by Rod was, as I recall it, is to what degree could we make the smoking status of the mother, and particularly a current smoking status amongst the mother at time of pregnancy, transmit to the child a higher propensity to initiate. So the idea being that the child is exposed to a uterine milieu that might elevate their risk of going on and becoming a smoker themselves. And of course, this is an interest of some generality, given the current interest in gene by environment interactions, interest in epigenetic effects, effects which associated with abuse of substances such as alcohol and FASD, and the damage that can be caused to a child through those intergenerational mechanisms, being exposed to an unhealthy uterine environment. It also is of relevance to chronic diseases as well. So we know since the work of Barker, pioneering work of Barker in Manchester, I believe it was, in the UK, there are some lifelong impacts of early life experiences, and recent research suggests that the in utero environment may impose some real impacts on a child. I know that in as of perhaps 5 years ago in rat studies, they had done studies of the impacts of in utero environment on a child, and found actually an effect that lasted no shorter than 7 generations of sort of impact from mother to child to child to child. And I was privileged to work alongside the director of the NIH Primate Lab in Poolesville, Maryland, who talked about similar research with rhesus macaques, which suggested, again, intergenerational transmission of factors that were associated with the environment of the mother to I believe 3 subsequent generations is what they had seen by that point. So this idea of intergenerational transfers is not an idle one. What is going to be a limiting factor is, we have limited time to characterize all the details of it, so I'm going to engage in a sort of simple first cut attempt to capture this. So what we're going to do here is we're going to need a mechanism by which a mother's situation, and we'll treat it as a dichotomous situation, is she a current smoker or not, at the time of delivery, okay? How does that transfer to the child? Now, in another model that I'm currently working on, and indeed that may be in front of Winchell's eyes even as we speak, we have a representation, a more textured representation of in utero exposure to a diabetic milieu, and some representation of glycemic control over the latter part of that environment during pregnancy, which as a continuous factor is is recorded for the child and might predispose them to risks metabolically. Here we're going to have simply a dichotomous factor. Okay. So what I'm going to do with your pardon is I'm going to add to the child a parameter. Okay. It's a characteristic of the child, and it's going to be a parameter that's going to record. It's a Boolean. It's going to record was I exposed to smoking during pregnancy or not. And again, we'll use it as a proxy just to smoking at the end of the pregnancy for now. So was exposed. I'll name it was exposed to smoking in utero. Forgive me, I lack a. Was exposed to in utero smoking. Was exposed to smoking in utero. Okay. This is going to be a Boolean, and to find Boolean here, we have to scroll up. Okay. Okay. And its default value will be false if we don't say something like that. Okay. So this is a parameter, ladies and gentlemen. And that parameter, the value of that parameter will be determined by the mother status at time of delivery. So if we go over to delivery here, we've been adding the baby into the population. How do we give it the value of this parameter that we've just added? How would we give it that? Yeah, so basically, when the mother delivers the baby, we will simply ask, is she currently smoking? Is current smoker? Okay? We'll ask, is she currently smoking? Is that okay? Okay. Okay. And that's going to be passed on to the child. Now, as it turns out, we need to, of course, deal with this situation in two other places in the model. Where are those places? If we've added a parameter to person, where else do we need to deal with that? Yeah, the initial population. Wherein does that live? Yeah. And you'll notice in main, when you come down here, this is actually a great occurrence to show this to you. You notice that this is because this is a dichotomous variable, a Boolean variable, this was exposed to smoking in utero, is a checkbox. We could check it or not, but that would be indicating it as some, very specifically default value. If we want to specify a formula for it, something that sort of with a certain probability, for example, is true, otherwise false. In order to do that, we need to use this little element here. And I always find this really confusing, and I'd like Winchell to take note of this as well. I always find this really confusing because I want to specify a formula, but if I click here, it actually just says static value or database reference or value editor. I think what you have to do is you have to do this static value, and it's kind of an odd name for it, but this is where we're gonna put the formula. The point is it's not changing over time. It's just for the initial population when they get created. So we shouldn't confuse ourselves to think it'll be changing for them over time. So we're going to put in a formula here. And that formula is going to involve flipping a dice or flipping a coin with a certain probability of heads. Okay? That probability, to specify it, I'm going to add it to main as a parameter. And it's going to be probability of in utero exposure to smoking. Boom. You could say among initial population or among initial population and immigrants. And what sort of parameter will this be? It's a double, ladies and gentlemen. Thanks. Double. Thanks a ton. Okay, so we'll make it 0.02, 2%. It might be something where we could gather some data from the literature. Perhaps we have some primary data related to this. Perhaps there's a large-scale survey instrument for a state or for all of Australia, which measures that. We'll use 2%. Okay. Next, we go back to the population, and now we need to take that probability, and with that probability, we want to return true, otherwise false. In any logic, this is a common need. It's so this kind of need to flip a coin, a weighted coin with a certain probability of being true. Or to put it another way, it's a Bernoulli trial. A certain probability of being true, otherwise false. And so what we can say here is, this built-in method is called random true, which I don't think is a particularly intention-revealing name. But I'll say, and it takes an argument to do its job, which is the the probability associated with that Bernoulli trial, the P, as it were. So there we are, and needless to say, I'd suggest you not type that. You just do autocomplete. Okay, that was the parameter we just added. So what this is saying is, with this probability, this will be true, otherwise false. Are we okay with that? Okay. Great. Okay, ladies and gentlemen. That's one place. And then the other place is where? Immigration. Let's just copy this formula, and we'll assume that, well, I mean, we could have a similar parameter for immigrants. Sure, let's do that once. So take that parameter and drag it down. So I took that parameter, I held down Control. I don't know what it is on a Mac. Command. And you drag down while holding that button down, then you let it go, and it'll make a copy of it. So probability of in utero exposure to smoking among immigrants. Sure. And maybe amongst the immigrants coming from a somewhat higher SES population, perhaps it's a bit lower, I'll say 1%. Okay? Are we okay with this? Okay. Ladies and gentlemen, now in the immigration event, we are going to do what? Yeah, and where will we need that? Where does it go in this code that stands before us? Yeah, it's the last parameter of add population now. Add population now. By the way, notice I'm using control space here, not just to fill out a name, but to have it tell me things. Notice by doing this, I can go look, and it could say, oh, this add population, it takes sex. Look at that, birth time. See this? Initial smoking state, SES, and was exposed to smoking in utero. That's what it's expecting as arguments. So command space or control space is not merely a means of filling out names. It's a way of getting information on what you're calling. It's even a way of getting information, not only what it expects, but what it guarantees, what job it performs. So here I'm going to go and I'll list these out, and then we're going to have a final parameter, which is basically going to be this probability, since we're doing immigration event, probability measure among, oh, what am I not doing? That's crazy. Random true of that. Remember, random true flips a weighted coin. It performs a Bernoulli trial that returns true or false. Okay? True, indicating that they were exposed in utero. False, indicating they were not. And random true takes a parameter. It takes an argument, as we say, that gives the probability of returning true, and we'll do the appropriate thing. Are we okay with that? Let's do build, ladies and gentlemen. Let us build early. Let us build often. Okay, great. Okay. What's the final thing we still have to do? Sorry? Yeah, we have to link it in. Right? Whither will it go? Well, it's affecting initiation, so it needs to somehow be factored into the initiation hazard. Does it not? It does. Now, here, there's a number of ways we can do it. Ladies and gentlemen, a number of ways that we can accomplish this. And when I teach these boot camps, I'm trying to identify fairly elegant, minimally painful ways of doing things, which typically admit to many types of implementations. I try to find a kind of least cost means of implementing it. And here too, there's a lot of different ways that we could implement that. I'll show you one way that I find fairly straightforward, conceptually simple, and mathematically understandable for those who are used to working with hazards in a biostatistical context. So there's this parameter, was exposed to smoking in utero. That's actually a Boolean, true or false. Okay? I'd like to flesh it, to place it in this context where we have this initiation hazard by age. So going back to look at, oh, well, here it is, right there. I'd like to place it in here as just another factor. So there's going to be main dot initiation hazard beta for in utero exposure. And then we're going to have, so there's going to be a beta times the occurrence of it. Okay. Problem is we can't multiply it by something, because what we have is a Boolean, true or false. Okay? So there's a couple ways we could do it, but just to preserve this nice feature, what I'm going to say is I'm going to have it be in utero exposure indicator. Okay, this is an indicator. It returns 1 or 0. 1 if they were exposed in utero, 0 if they weren't. If you're used to reading some technical papers, they'll have an indicator function, I, and it's used to indicate is it present or not, it's 1 or 0 otherwise. That's what I'm sort of riffing off of here. And I'm just trying to keep the kind of consistent pattern that we have this exp of, a beta times a factor plus a beta times a factor plus a beta times a factor. So I just want to have this indicator, okay? It has a certain virtue of understandability here. The other possibility, which I'll tell you, and if there's acclamation, I'll proceed down that direction. Let me show you the alternative. The alternative is very straightforward. The alternative is no problem at all. We could just say the name of the parameter here is, let's go back to this. The name of the parameter is was exposed to smoking in utero. So we could do basically was exposed to smoking in utero. If so, use this beta, otherwise 0. Okay, and then like that. And basically, this question mark is it's like an if statement, or if operator in R, if expression. So if this is true, we're going to use this, otherwise we'll use 0.0. I find that a lot of people don't know what this question mark means. It's just, I think it's a little bit easier to have it this way. But if there's acclamation, you wish for me to do it this way, I'll accede to the voice of the people. Okay? Sorry?
The top way is nicer.
Yeah, okay. So thank you. I'm glad my aesthetics are shared amongst at least some. Okay, so ladies and gentlemen, what we need to do is define this. That's all. This indicator, okay? So we're going to pull in a function. Maybe we'll put it up with these functions. Oops. Okay, it exhibited bouncy behavior. Here we are. Boom. There we go. Okay, and I'm going to define a function called the interutero exposure indicator. Oh. Okay. This returns a double. Returns 1 or 0. And to make it very clear to everyone, if was exposed to this in utero, we're going to return 1.0, else return 0.0. Note the semicolons after the 1.0 and 0.0. Are we okay with this? The room doesn't resound with response. But I'll take that as a yes. Okay. Okay. And then finally, we just have to, I showed you what I wanted to do, and now I'm going to copy the code to do it. There it is. There it is. We're just inserting this at the end of that thing. Now I'm going to put this there so you can see it in place. There we go. Remember, it doesn't care about sort of the spaces. So here we go. I'll spread it out, but I'll put it up on the big screen so you can see it with greater clarity. I'll wipe away this alternative. Okay, there we are. Oh, do you see it? See or not? See, okay, good. Okay, so there's an age-based initiation hazard, and then we have a exponent of these betas times these factors, and this is just the latest one of them. This returns 1 or 0. We just created that. And this is the beta, which we're going to need to create. We're going to need to create this in main. We haven't created that yet, right? We're going to need to create this guy in main. Are we okay with that parameter? Can we proceed to main? I'd like to highlight one thing for you, in case you didn't catch it, is this. That function that we said we indicated returns a double. In general, with functions, they either undertake an action, they do something, they connect two people, for example, or they perform a birth, or they kill someone out of the model, or they record someone's state to a database. They perform a function, or they perform some action, or they return a value. And here it's returning a value. It's returning 1 or a double, either 1 or 0, 1.0, 0.0. Okay, so now what lies before us is to add this guy to main as a parameter. So let's go to main. We're going to drag in this parameter, and we're going to add it. There we are. In utero exposure. is going to add, I'll make it 1.0, meaning that if you're exposed in utero, you're nearly a 3 times, 2.71 or so times the chance of of initiating. It's a hazard is that much higher. So the hazard rate is almost 3 times as high. Where did I get that 3 times? Well, if you had a 1 here, then this can be 1 times 1 added onto this. And if you have exp of a plus b, it's equal to exp of a times exp of b. And exp of b here is exp of 1, which is 2.71. So it's just going to increase what this exp would be by a factor by multiplied by 2.71. Okay? Are we okay with this? Okay? Okay. May I run it? Can, cannot? Yes. Okay. Here we go. Okay. Okay. So let's run, ladies and gentlemen, shall we not? Let us run the baseline. Here we go. Here we go. Now, here we have information. The population is undergoing turnover. We do have clustering and so on. But it's not clear how this has changed that. I mean, we don't have obvious visual connection between a mother and her child or anything like that. Oh, so let's go add that. Let's go add something. Let's have a way of communicating for those who have in utero exposure, what fraction of them are current smokers versus amongst those who do not have in utero exposure. What do you think? We could have 2 pie charts. One for those who are exposed in utero, showing what fraction of them are smokers versus former smokers, etc. And then we could have a similar pie chart for those who were exposed in utero. And that will give us some visual sense. And of course we can accumulate the statistics, so they'll be shown there as well, regarding the differences between them. Are we okay with that? Good. Okay, great. Great. So let us proceed. So where would we add that pie chart? Main indeed. Whence would we retrieve a pie chart? Whence would we find the pie chart in the palette? It's a good guess, but it's actually in analysis. Yeah, sometimes it's easy to get confused because both of them add sort of visual elements. Analysis is our choice for the day. So we'll put this up here at the top. After all, with the Winchillian contribution articulated earlier, we feel in command of allowing us to navigate around our menu with considerable ease. Okay? So I'd like to drag in 2 abutting pie charts. 2 pie charts, ladies and gentlemen, for the 2 segments of the population. Unfortunately, they're named in a very generic way, chart. We're going to call this smoking status of in utero exposed pie chart. You can criticize the names, and I welcome criticism, but at least one thing you won't be able to say is that it's really easy, it's very hard to know what they refer to. They have a certain naming transparency. Okay, so we'll have one pie chart there. That's good. And, oh, there we are. Okay, and ladies and gentlemen, we will next go and, oh my gosh. Okay, I was trying to copy it. Okay, this is most interesting. Okay, okay, that's really Look at that. Take a look at that windshield. The ghost chart, ladies and gentlemen. Do you see it or do you not? So let's look over here. Let's look over here. Go in projects and let's go see underneath main. We'll go within main and we will go look at analysis. We'll go look, confusingly it's under presentation here, which is kind of curious. And here it is. Look at that. Smoking status. I actually copied it several times. And there it stands in all of their glory. But where are they? We see them not. Okay, I'm going to delete a couple here. We only need 2 after all. And I am going to move, oh man. Okay, I'm going to close AnyLogic and reopen it. What do you think, Winchell? Advise it or unadvised? Okay, I missed that quip, but here we go. Okay, let's go back to main, and here we go, and we'll. Okay, Winchell. They still are invisible.
Okay, I would make sure that it is recorded.
Thank you. Thank you. Okay, well, we have invisible pie charts, which may offer limited benefit. I guess maybe those are low-calorie pies.
Change the border color to black.
Yeah. So we could frob the colors. I think that's a fine idea. Appearance. Okay, background color. Let's make them. The fox has shown its tail. Okay. Okay, here we go. And here's the other one. Okay, there we go. And we'll change its background color to be, maybe this one will be green, this one will be red. Okay. That's a most peculiar circumstance, but it's one with which we can live. Okay, so this is smoking status of in utero and exposed people, pie chart. This other one is smoking status of non in utero exposed pie chart. Okay, great. Okay, we stand at the cusp of being able to build these, but there's one thing missing from the model. Tell me what I'm going to put into these pie charts. What information, what data will fill them? Counts of people who are what? Indifferent smoking stati for each of those groups. But how are we going to compute those? How would we compute those numbers? What's the easiest way in AnyLogic? With a with statistics and population. After all, those are cross-sectional measures. How many people right now are in each of these smoking categories for those who are in utero exposed? But have we defined those counts already? No, let's go do that. It's a quick matter. Okay? Go to main. And in main, we'll go to population. Here we go. Population. And we'll go down in population to statistics. We have count former smokers, current smokers, and never smokers overall, which is a great start. But what do we have to do beyond that? Yeah, we have to We have to do that by exposure status. So we need further qualifications. We don't want to get rid of those, but we can make use of them. And notice that AnyLogic does provide a way of duplicating them. So let's duplicate this twice. Why twice? Yeah, one for the general. One is for the general. One is for the in utero exposed. And one is for non-in utero exposed, right? So I'll just get the names right. Non-in utero exposed. Or you could say in utero non-exposed, but okay. Ladies and gentlemen, how do we have to change these latter two compared to the first? What do we have to do? What further qualifications, what further criteria do we have to add here? Yeah, we have to check if they're exposed. So the criteria is going to be not only, for any are exposed, not only are they in this state, but they are also what? Exposed, ladies and gentlemen. Exposed. Okay? Item dot was exposed in utero. How about for this? Oh, sorry. I don't want to add that to the overall one. I want to add that to the one for in utero exposed. We're counting up the number who are both current smokers. That's this. And were exposed in utero. And you may notice I use this and sign. That's how in Java we say this criteria and this criteria. This whole thing will only be true if both the first thing, that they're in this state, current smoker state, is true, and if they're exposed. Are we okay with that? Okay. How do we adapt that? How would people like a bit more time? How would we do it for not in utero exposed? Well, it's just a little bit of trivia regarding Java. We need a not here. A not sign is indicated as an exclamation point. Okay, that's how we say. So here, someone's only going to be in this category. Count former smokers non-in utero exposed if they are a former smoker and they were not exposed in utero. And that's why we use this not, we indicate not with an exclamation point, confusingly enough. Okay? Are we okay with that? The same basic criteria is going to hold for each of those other two. For each of former smoker, we'll create similar categories. Each of never smoker, similar categories. Sorry, this is for former. Oh, I'm confused. I am the confused. Okay, wait a minute. I thought I copied this twice. I only see one of them. And the other one I added to the former smokers. We got to be really careful here. That's okay. Just you need to make sure there's 2 copies of each of these. Okay, so we have to be very careful here. There's current smokers. There's this. We want current smokers in utero exposed, and then also former smokers non-utero exposed for current smokers. There we go. Oh my gosh. You notice it does that occasionally. Okay. There we go. And same thing with former smokers. We're going to have 3. One for the overall, one for those who were in utero and exposed, one for those who are not. Here we go. Boom. Boom. Okay. Okay. Former non, here we go. Boom. Okay. So there's going to be still account former smokers. Then there's going to be account former smokers in utero and exposed. And there's going to be count, yeah, I know, there's weirdness sometimes. Okay, there we go. And then account former smokers, non-in utero exposed. There we go. Next, current never smokers needs to be duplicated twice. Once and twice. There we go. Okay, for each of those, we're going to need the similar machinations. Okay, there we go. And similarly for this. Boom. Boom. Okay, next we're going to name them appropriately. So we have in utero exposed and non-in utero exposed. And I'll go over and overview this to make sure we got it all right. A little bit tedious, but it will carry the day. Non-in utero exposed. Okay, so here we go. Let me do this from the top down. So for each of these smoking categories, current smokers on the one hand, former smokers on the other, never smokers on the other, for each of them, there's going to be a sub-variety. Beyond the basic one that counts the overall group, there's going to be a sub-variety. Count that variety for the in utero exposed, which is going to have this further criteria that the person was exposed to smoking in utero. And then another one that's not in utero exposed, which is very similar, but it says not. They were not exposed to smoking in utero. Okay? Or to put it another way, there's 3 for the overall counts, current, former, never. There's 3 for the counts that take those overall ones and add the further criteria that they're in utero exposed. And then there's 3 that do it for not in utero exposed. Okay? Are we okay? Who needs more time? Okay?
I'm getting a lot of hourglass.
A lot of what?
A lot of waiting time from the computer.
Is that right?
A lot of hourglass.
Okay. Oh, okay. Would you like a TA deployed?
I'm almost there.
Okay. 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 Okay, who needs TA help? Annie's circulating. Okay? Okay. Ready, ladies and gentlemen? First of all, we should build, just to make sure this part is a happy camper. And then we will finish the job. What's the finish of the job? Yeah, we have to refer to these from where? Yeah, well, we have to refer to them from these pie charts, right? The pie charts, ladies and gentlemen. Okay? Okay. Okay. Here we go. Ladies and gentlemen, let's go add items. So this is the smoking status of in utero exposed. And so we'll add 3 items to this. You know, it would have been actually, now that I think about it, it would have been actually easier if we had gone and simply duplicated this one. Remember we had this one? Remember this one? Which was recommended by a non-ghostly appearance as well. Do you want to do that? Do you want to make a copy of that? What do you think? Since it's already defined, all we have to do is tweak the names on it. Okay, let's get rid of these 2 ghostly pie charts. Glaring in there. glowing in their glaring presence. Tawdry? Okay, yeah. Okay, ladies and gentlemen, one thing we can do is we can go down to this existing pie chart and we can do copy by right-clicking on it, copy, and then we can paste it. Now, normally I'd like to kind of drag and control and so on, but that gave us the weird ghosts earlier. So I right-click on it, copy, and then I'm going to try, and I'm not very good at this at all. In fact, I'm rather poor. I'm going to try to click on something elsewhere where I'd like it to go, and I'm going to try to say paste, and just hope it appears nearby. Ah, it did. Okay, there's one, and I'll click nearby and do right-click paste. Ah, the other. For once, they appear at the right location. It's often I have trouble with that, and hence my recourse to dragging. Okay, so here we are, 2 pie charts. Are we done yet? Not quite. We have to set these pie charts to have them be different from the other pie chart. What do we have to do? We have to set them to use the appropriate subpopulation. So this should be smoking status pie chart in utero exposed. And this uses, instead of count number exposures, it uses what? Well, now we can do autocomplete. In utero exposed. Boom. Make sure there's not double parentheses. Here, count current exposures. Smokers, rather. In utero and exposed. Boom. Former smokers. Former smokers in utero exposed. Boom. There we go. But we should probably say amongst in utero exposed. We should probably label that for each of these guys. This is a pattern in any logic of considerable note. You copy something and you frob it. You engage in frobbing behavior with it. In fact, it probably would have been even more clever if we had copied it, modified it, copied that, and then just tweaked it. Here we go. For the other pie chart, smoking status pie chart among non-in utero exposed. What do you think? Good or not? Okay. And next, we're going to set it to call the appropriate methods in the population non-in utero exposed. Ladies and gentlemen, non-in utero exposed. And for the final one, non-in utero exposed. Oh my gosh, it looks like in the statistic in the population I had a 1 at the end of its name. I'm going to go correct that because I don't want that 1 there. There we go. Okay, I'm going to go correct it whilst you continue to frog. Okay, here we are. Boom. That was the offending one. And here we go. Boom. Okay, great. Okay, so back to the salt mines here. Okay, I'm going to go back up here and just make sure we finished properly. So now we got to label each of these accordingly. Never smoker among non in utero exposed, and we could just copy that for each. We're just about done. I think we're all finished now. Okay, done. Okay, who needs TA help? Okay, TA in sector 1, front. Ladies and gentlemen, who else needs TA help? TAs? Nope. Okay, ladies and gentlemen, I would invite you to run the model if you feel comfortable with it. With so doing. What should we be expecting up in those pie charts? What would we expect to see? Anyone?
More smoking.
Yeah. You'd expect to see more smoking and in utero exposed. Now, there's some confounding effects because people are being added to the population claiming that's in utero exposed, but they're in fact not in utero exposed. They were, but they weren't subject to the associated risks earlier in life. Here we go. Okay, here's current smokers in lighter blue and former smokers in darker blue. Okay, amongst those who are in utero exposed, we've about 40% right now who are current smokers, compared to, or 44%. Looks like it's still going up. I'll let it continue here. Not marked differences, as far as I can tell. Not marked differences. We do have immigration. It's a somewhat confounding factor because we're saying some of them are exposed in utero, but they actually end up not having the smoking rates to suggest it. But nonetheless, there's not a profound number of individuals exposed in utero who are smokers. Okay. So I want to probe this further. I'm going to experiment. I want to see, just as a sanity check, in the extreme case where it has a very big impact, are there individuals indeed who are individuals more likely to become smokers? So I'm going to copy this and I'm going to paste it here. Boom. And I'm going to say strong in utero exposure impact. There we go. And I'm going to raise this up from 1 to 3. I'm just going to see if we had many times the impact, does it in fact lead to this? So what is it showing in yours? Is it similar? Only very modest, if any, impact?
Yeah.
Yeah, okay. So I'm just going to go to person here. And let's go check that out. Just making sure that this is yes. So we have that in utero exposure indicator. So the question is, clearly there are people who are in utero exposed here. Let's try running this out. The years pass. Let's try going down to the population while we're waiting. So this is a person who was exposed in utero. They're in a never smoker state. I would have thought that they would. Okay, so they're quite older now. Okay, the person has died now, so that disappeared. And that person has died as well. So I'm going to go up to the top level. Here we are. Okay, there we go. There we go. Okay, yeah, so I don't see much influence here. What gives? What gives? This is puzzling. Okay, one hypothesis I have is it's because a lot of the individuals who are marked as in utero exposed are coming in from the population from being added as immigrants. So we're going to basically make it so that those who are immigrating are not in utero exposed. Because those who are immigrating, we're just assigning them to random smoking status. It's possible that that's a confounder hiding this impact. So for this, to investigate this hypothesis, I am going to go to the immigration logic, and I will go here and check for the immigration event, and I am going to, for immigrants, for now, I'm going to say that we're going to assume that they are not in utero exposed, since we're just assigning them to a random distribution of states. I don't want them to distort the information for those who are exposed in utero. I'm going to run this now and see with that cleared up, does that make it any clearer? I'm going to go look at my logic here. Oh, what I meant to do was to run the one with stronger impact for in utero exposure. I meant to run this one. Here we are. So I'm investigating what the outcome is when we have very strong in utero exposure, and it's only limited to those who are born into the population and therefore who are followed from birth. Here we go. Okay, let's try this. Meanwhile, I'm going to look at my logic here. Okay, that should be fine. There's an in utero exposure indicator, which was 1 or 0, depending whether they were exposed. And there's the initiation hazard beta, and this is all added into that. I don't see how that could be too far off. Okay.
Could you look at the numbers in your month smoke?
In the
Like just to compare the numbers across the two?
okay, so there's comparatively few in utero exposed here. There's about 137 there, whereas the other there's much larger fractions who are not in utero exposed. So we're dealing with a smaller set here. We are dealing at the moment with a slightly larger fraction who are okay. So yeah, it's sort of neck and neck with this. Okay, something is off here. Something is off because I would have expected a very pronounced effect. Let's go look at if we were to take a look at this. Okay, so why is it they're not becoming current smokers? So let's take a look at this more closely. Okay, once again, we have an initial population that starts divided randomly between components. So I'm going to set was exposed to smoking in utero to false for those in the initial population, in case that is somehow really affecting the numbers, because maybe we're dealing mostly with those who who are initially in the population exposed. So I want to see, is it possible? That's really bringing down the numbers here. So here we go. So now we have people being, there's not even any of these so far. Okay. These are never smokers thus far. They're young. They've been born into the population. Here we go. Okay, so this is a younger population, which is a confounder than this one. Already we are seeing quite a few having uptaken. These are, again, all individuals born now into the population and therefore being followed thus far. Here we are. We still see a surprisingly small fraction who are current smokers. A lot never become current smokers, and it's fully. I don't see any big differences between them. Okay, let's take the extreme case. Let's take a case where it's e to the 5th times more likely that one will become. The hazard rate is that much more likely. Here we go. Okay, we're going to go down here. Okay, go down. Okay, some of these will be becoming smokers now. Yeah. A growing fraction are becoming smokers in teenage years. Okay, so still, I would have expected just about all to become smokers now, and I'm still not seeing that. Okay, so what could be going off here? I'm going to make a copy of this model for debugging purposes, and I'm going to start poking at it. Here we go. Debug. Boom. Okay. So I've saved away a copy. I don't have to worry about damaging it. Here we go. There we go. Okay, so what could be wrong here? How is it that they're not possibly initiating? I mean, this is bizarre. So one hypothesis is this is not being recalculated frequently enough. This is calculated every 1 month. So this has got to be calculated. Okay, nice thing that we can do. Wouldn't this be a great thing? Okay, ladies and gentlemen, let us create a function. Functions, ladies and gentlemen, are your friends. So this function is going to be initiation hazard. Okay? And it's going to return a double. And its job in life is going to be to return the same calculation. Initiation hazard. But it'll further print it out for, there we are. There we are. Okay, so we're going to return that, but we're also, I'm going to make a copy of the value. So initiation hazard, here we value equals this. That's great. And now we're going to return the initiation hazard value. That's great. And I'm going to print this. I'm going to print it out. And I'm going to further print it out for each of them. You know, if, so here we go. If this dot was exposed to smoking in utero, trace ln, exposed in utero, initiation hazard, and I'll print this out. There we go. initiation hazard value. Else not exposed in utero, initiation hazard being such and such. Okay, great. Okay, here we go. Okay, it's an unhappy camper, and as a hazard value cannot be assigned to a value. Okay, oh, I misspelled it. Boom. Here we go. Okay, so basically I'm probing what is this value. Is it bigger? And I do that by printing things out. And the way I get it to print something out at that nice little point of calculating it is I call a function, which does the calculation, and before the function returns, I print something out. So let's go see if it's a happy camper now. No, it says initiation hazard. Okay, I still misspelled it. There we are. Boom. There we go. Boom. Okay, and initiation hazard, I misspelled it there as well. Great. Okay, the rate is initiation hazard value. Initiation hazard. There we go. So we call the function, and the function prints things out. Man, I hope my students will follow this. Could learn to debug. Okay. Here we go. There we go. Okay, high in utero exposure. Let's go run this. We should see considerably higher values among the in utero exposed to not. Now these things are printing out. They're printing out here. Okay. Okay, let's see if we could pause this. And, well, sure, we can. I'm going to copy these. Yep. Okay, it's not letting me copy all of it. I'm going to have to pause it. Boom. Here we go. Copy. There we go. Boom. Not exposed. Okay, where is an exposed? Here it is. Exposed in utero. 0. Okay. Now, boosting 0 is not going to be helpful. 0. Exposed in utero. Here we go. Okay, yeah, these are a lot higher. Exposed in utero. Boy, are those high values. Okay, 0 though. Yeah, when they're beyond a certain age, it doesn't matter. Okay, great.
Could you get death rate? Dying too quickly?
It's a good idea. It's a good idea.
My euro just the population growing because the smokers keep dying.
It's possible. We could look at what would be the mean year of age at starting smoking among in utero exposed individuals versus not. Seems to be. It seems to me that it's. Really what we'd like to do, to compare apples with apples, we'd like to compare those who are born into the model among in utero exposed with those who are born into the model among non-in utero exposed. That's what we'd really like to do. And instead, we've kind of got these, including lots of people who are not born into the model, or were in it initially. These are the only born into the model. And as a result, we have two different population profiles. Okay, that's a bit of a pain. Okay, I am going to. That's puzzling. Okay, I could do that. I could basically keep track, are they born into the model, and only summarize among those who were. I've never done that before, but sure, let's do that. Okay, so here we go. I'm going to open that model. It's going to be version 13, and we are going to, version 12. We'll reopen version 12. Here we go. This is my version. I'll go post this up on the site if anyone wants this. And I will I will go modify it so I can do an apples to apples comparison. Classes here, okay. Okay, models, boom. Okay, there we go. Should be pretty quick to do for me. Yeah. Good. Okay. Yeah. I wish I didn't have to do that, but here we go. Okay. So I'd ask you don't feel you have to do this. I'm just going to do it right now so that I can debug this, and then I'll if we can't pin it down within 10 minutes, I'll basically move on to something else. Okay, so here's a parameter, was born into model. That is a parameter that is a Boolean, and here we go. And we are going to have this basically be false for those who are born into the population. There we go. Okay. For those born into the population. Okay. Okay. Oh. Okay. So what's going on here? I called it S. Okay. Get rid of that. It's a Boolean. Were they born into the model? And then we'll go to main population. Here we go. Okay, and we'll say for those who were in the initial population, that's false. For those who were in the immigration, that is false. That is going to be false here. For those who are born into the model through person, this is in fact true. Okay, boom. There we are. True. Okay, there we go. Okay, here we go. Boom. And we're going to say true because they're being born into the model. Great. Now, all we have to do, so we just indicated whether or not someone is born to the model we're going to build. It's a happy camper. Next, ladies and gentlemen, we're going to go to the population, and for the statistics here, we are going to only accumulate these statistics for in utero exposed for those who are is the food out there? Yeah, okay. Well, we'll let them go within 5 minutes here. Who are born into the model. So here we're going to say and was what did I call it? Was born into model. Yeah. So that's correct. So here we are. Okay, and item dot was born in model. Okay, was born into model. Okay, and I'll do this for all of these guys here. All of these ones that are counting in utero exposed and not in utero exposed. We should update the names. There we go. And this guy similarly. And then this guy. Okay. And then this guy. There we go. Boom. Okay. There we go. Okay, now we can run it. So I'm going to run it now, and we'll see what happens. And we'll see if there's a pronounced difference. Was it due to those confounders of these populations that were not born in? There we are. Okay, they have to get to a certain age to start uptaking. But now we're comparing apples with apples. This group and this group only include those who are born into the model. Let's see how they compare now. Here we go. Okay. The fox is showing its tail. Ladies and gentlemen, looks to me pretty clear. Basically, what we're having is a situation where those numbers earlier were distorted by the fact that those who were being summarized here included many that were not born into the model. The immigration rate is high enough, and the size of the initial population was high enough that we had these statistics really distorted by those who were not born into the model. And now we are getting a situation, seems to be the case, where we have considerably more uptake by in-utero exposure. Not as big as I thought still, though. But okay, I think we'll have a break now, and I will meanwhile continue to look at this thing and see if I can firmly figure out what this is. Okay, so we're going to have a break for 20 minutes. Is that right, Jeff? Yeah. Okay. Okay. So Winchell, I'm going to need your help in debugging this. Okay, thanks. Okay.
Summary screen view that one can pull up without any logic, which just lists in text form everything that you put into the model.
Yeah.
So
Yeah.
you can just see, I put an extra zero in that B value before.
Yeah, yeah, you can create documentation on them.
Oh, okay.
Yeah.
And it'll spit out.
Yeah.
Just so you don't have to click around all the different
Yep.
elements.
Yep.
To
That's right.
investigate.
Yeah, it'll generate a PDF or a
Okay.
Word file that
Just
contains
get a
all that.
page or
It's a
two.
good point. I'll see if I can point it out to people. Okay. Yeah. Yeah.
Mine as well, so that's right. No, not this one. Look at the age distribution.
Yeah.
Just ask a question.
Sure.
That interval is similar.
Yeah.
Like each person.
You see what it means? Like,
Their networks?
Yes.
Yeah. Uh-huh.
And it's distance based.
this
Is that
is
in a
a
circle
table.
around
It's
the
essentially.
Well, it basically connects two people if they lie within a certain distance. So basically, yeah, so it's a radius around them.
Yeah.
Yeah.
And so we've got the
Why do you use function table? But
plane that they're in is 500.
Or the other way around.
That's right, yeah.
So
Yeah.
only in that
So
case,
if
it's not.
a child is born,
Yeah.
we're putting them on the same X
Anyway,
plane.
That's correct,
actually
yeah.
We're
why.
not putting them close
To the mother
to
necessarily.
So
That's
they're not
correct.
necessarily in the mother's network. Is that?
Really
This is correct,
annoying
yeah.
me.
That's.
Right now, well, I mean, I have plenty of other models which do connect them, but I didn't
No, you can put both of these
want to
together. So
take the
all
extra
your
time to
rows
do that. So,
being on the
yeah,
top.
but yeah, we can put them pretty easily next to the mother, and there's some of the models I provided you do that. In fact,
So
yeah,
that's
yeah.
only for density and probability, where these are specific values in the tangent.
You could also, I should note, you can also actually manually connect them wherever they are. They can be connected to their mother. Yeah.
The probability,
Yeah.
probability of those things coming.
Yeah. So have you been following at all the dysfunction?
Yeah.
Yeah. So this is really puzzling. Like, these folks are many, many, many times more
It
likely
is a density.
to become
I think. I don't know. Is that the thing? Just you get the model set exactly the same model you get, or they're talking about another?
well, I mean, essentially these folks should be almost guaranteed to become smokers, and they are not doing so. It's almost like it's not recalculated the rate, but it is
You're saying the
recalculated.
hazard ratio.
So I'm just really puzzled. I mean, a lot of things seem
Use a table function.
actually very straightforward. So right now they're not, because they're not yet of age to. And then it starts out really very likely,
Uh-huh.
but you would expect it to become essentially everyone,
Right.
and it's not. It's not becoming
You
everyone.
turn off the migration, right?
Sorry?
You turn off the mean migration, right?
Well, this is no longer summarizing people who are migrants. It's only those who are originally born into the model.
Born into the model.
Yeah.
Including those kind of babies, descendants of those original
Yeah,
residents.
that's correct. Yeah. Yeah.
But,
So
but the initial ones, the babies are.
Sorry,
are,
I'm just, like,
are
I'm
born
just
to
trying
be
to,
smokers?
trying to think.
Do they have a safe time to be non-smokers?
Sorry?
Like, does the baby, the descendant,
uh-huh.
when they're newly born?
Yeah. They're non-smokers.
Yeah.
But they just have much higher initiation rate.
Yes, but then maybe you can just like the people showed in chart here. What's the age
Which is
range?
the
for that? Can you just rule out those very young people? Just try to see what it believe.
I understand what you're saying. You're saying it could be distorted by births.
Yeah.
That we have a disproportionately. But that's true. But that would distort each of these in the same way.
Right.
That both of these should have the same fraction of young people.
Okay.
So you'd still expect this to be higher.
Right. Right.
Oh, okay. So I will certainly agree that that's the reason that could be a viable reason not all of these are
Right.
I think it
Um,
would be different.
Well.
smoked. So yes, we could.
I don't know.
So I like that
That's why I
idea
have the
though.
question.
Let
I
us
wasn't
go.
sure.
Let us go limit that
Yeah, and then we'll
to by age. At least it'll be clearer, right?
Yeah. And then we can.
Okay. So let's go here. Population. And let's go down to statistics. So this is here we go. Boom. Right? Here we go. There's the population. And
Okay. Sorry, no, I'm just truly curious.
okay, here we go. Okay. So we're going to limit those to those who are between certain ages.
Yeah.
Right?
Yeah.
So they need to be at least, we'll only consider them if they are at least 15 years old.
Right.
Or, I think actually we started at 11 was the kind of youngest. Let's just go
Yeah, I
check that
think
out.
so, yeah.
I think it's 11 was the youngest age at which we were considering someone as having a non-zero hazard rate. So let's just go here. Initiation, hazard by age, 11. Okay, so I like your idea. Let's sort of rule out maybe those statistics are being, highly distorted by the fact that we're computing the whole population, which includes lots of children, and those are basically of necessity all non-smokers, and therefore it's confusing things. We can at least see if it's working more easily if we rule out kids, right? Okay, so here we go. Item dot current age greater than or equal to 11, right? Eh? So we'll copy that for all of these criteria, right? True or not? Right. Okay, and then we'll skip it for this guy, and we'll do it for this guy, and we'll do it for this guy, right? And we'll skip it for the overall, and we'll do it basically for all these where we're comparing in utero versus non-in utero exposure. Okay, we're done with that. Here we go. Okay, and now we have a magnificently larger chance of becoming a smoker here if you were born in utero. Okay, let's go up. Okay, so there's no one yet who's in this because they're too young. The ones who are born into the model. So
All the
here we
people
are.
in the model
We're going to start to get.
All the people are 0 years old when they're born into this model. But anyway, it's quite interesting now.
They're all 0 when they're born in. Yeah, so this is the answer. It was just there's a confounder, namely those who were too young. And it was, and I guess the birth rate is high enough that it's
to diffusing
Overwhelm,
or whatever.
it was overwhelming the statistics. Now it's interesting because we're comparing in this latest version apples with apples, So you would have thought it would be a little bit larger, but because of the stochastics.
Yeah, because the population size would be different, then the number of kids would be different, then that's whatever something.
That's true. It's just you'd think the proportion of kids.
Yeah.
But then again, some have the smokers have
They die fast.
They die faster.
Yeah.
So they would have more. It's
Yeah.
kind of a fresh.
A larger fraction
blood.
of children.
Yeah, whatever. They have faster kind of a.
Yeah. So here, essentially everyone is a smoker.
Yeah.
Here, but here, okay. This is still curious, though. This is among those who are born into the model and greater than or equal to 11 years old.
Mm-hmm.
3/4 are smokers here.
Mm-hmm.
But wait a minute, I know why that is. Okay, yeah. Mumble. Yeah, I know where that is. Yeah, this makes sense. Because there's a synergy going on. Because we also have this. Okay, that's really interesting. Okay, this only directly affects those who are born in utero.
Mm-hmm.
But it indirectly affects others through this sort of smoking
Cutting
connections.
Yeah.
Right?
Yeah.
So it does end up affecting.
Yeah. You think about writing a paper on this?
That is really interesting.
That's interesting.
That is really interesting. Okay, so now let's try this. Same thing. That's an emergent feature that I didn't think to anticipate, but which is really, really fun. Okay, so this is no contagion. We're going to turn off contagion, right? Incidentally, this is being recorded. Still, I didn't stop the recording. It's good.
Filter something.
Yeah. Okay. So let's turn off the contagion here. Right? Good or not?
Right.
Eh? Okay. Turn off contagion. Right? Okay. Now let's see what those graphs look like. We still have really, really high chance if we're in utero, it's just crazily high chance of being exposed. So basically, what's that?
Maybe you should set a view area.
Yeah. Okay. Fair enough. Okay. Let's do that while it's running. Okay.
This needs to be very high.
Okay. Okay. Come on. Okay. There we go.
Indeed, parallel working.
Yeah. Okay. So. So this is a presentation view area, right? And this we'll call pie charts, smoking status by uterine exposure. What do you think?
Good.
Good or
also,
not?
Also the name.
Name.
Also the name. Because otherwise, probably not. But
Oh, yeah. View. Good or not? Okay. See, there it is. There it is. That hypothesis has been supported.
right.
Basically, there was a twofold thing. Oh, that's great. That's great. Do you see what I'm saying?
Yeah.
So there were two issues. There were two
Right.
fundamental issues that
Yes.
were bedeviling this.
Yeah.
One is a classic epi sort of data analysis issue. Basically, we had a confounder because we had children included, and that was yielding the statistics to be less different than they would have been. We had lots and lots of kids. In fact, I think we had more kids somewhat more kids among those who were not exposed in utero. We had more kids among those who were exposed in utero,
Right.
proportionally, because the older people were dying sooner,
Yeah.
right?
Yes.
And so you had more proportion of kids, which is increasing that. So that was issue one.
Yeah.
Issue two
Right.
was the fact that basically the very high rates among here were transmitting over to end up driving high rates
Yeah.
among the non-in-utero exposed individuals.
Yeah.
And so they were less pronounced than you think, because each of those in-utero exposed people who became a smoker
Yeah.
served as a nucleus
Yeah.
for all these different people,
Yeah.
regardless of utero exposure status.
Yeah.
True or not?
Yeah. Crowd effects. Though each one may be diminutive, the whole effect is
Mm-hmm.
whatever.
Yes, exactly, and that led to a very large proportion of
Yeah.
these being smokers.
Contention or whatever.
Yeah.
Yes, well,
Look at this. This is like night and day. Now let's ratchet it back. Okay, so we will go back to this population baseline. Okay, I mean it's a really good lesson because that's an emergent feature that I didn't see. It highlights the difficulty reasoning about it, and highlights what can be devil in real data too. This issue with kids and so on. Okay, initiation hazard for beta for in utero exposure is 1, so they're about 2.71 times more likely to. Their hazard rate is 2.71 times higher. Fine. Let's go look at that now, since we're confining it to this population. Okay. Here we go.
view area.
What's that?
No view area.
Yeah. Okay. Yeah. Good point. Well, okay. Yeah, mumble. Okay. Well. This is with modest level of impact, right?
Yeah.
Yeah. Okay. But still restricting it to the right subpopulation, right?
Right.
The fox is showing its tail. But this is also becoming quite big. And it's clear what this is really distorted by.
Yeah.
Contagion effects.
Yeah.
This is bigger, but this is big as well
Yeah.
because of the contagion, right?
Yeah, and because people are mixed.
Yeah.
Mixed.
Mm-hmm. Exactly. This is somewhat bigger, but this is also quite big, right? Meanwhile, if we ran this baseline, I'm gonna have to be careful here. Paste. No contagion, right? Baseline, no contagion. Well, we actually had that already. No contagion, but fine. No contagion. I'm going to turn off contagion, right? Right?
Yeah.
Good or not?
Yeah.
What do you think it will be? What do you think? Will it be? Oop, sorry. Yeah, it is. It is. Do you think it'll be a big difference?
Probably.
I bet it will be a sizable difference between them, with no contagion.
Yeah. Then it's just only connections.
Only. Well, basically now, because contagion effects are ones that both are affected by,
Yeah.
so it's going to be an equalizer.
Yeah.
Um,
Kind of smoothing
Yeah.
the difference.
Yeah. Now, one thing we don't have here is the sortivity. So having these folks. Okay. Now that's.
Maybe it can speed up.
No, it's going. Oh, yeah. Thanks. But. Yeah. Okay. So why is that? Okay. Okay, let me just check my understanding. No contagion, but we do have this, right? What's that?
Was it the birth issue that was?
Well, so there were two issues, it turns out. There were two issues. Issue one, and I'll cover this after people return. Issue one is that we were looking at a population which was confounded by having lots of young people. And as a result, the statistics between the two were not, they were being, in both cases, they were diluted by the fact there were lots and lots of never smokers just by virtue of age. And that ended up shrinking, any differences for those who are current and former smokers. The second major issue, though, was a more interesting one. We had contagion on. And so I was thinking, my mental model was that the individuals who were in utero exposed would have much higher rates of smoking than those who were not in utero exposed because they were being driven by these this in utero exposure factor, whereas the ones who were not in utero exposed wouldn't be driven by such high rates. But what was going on is that the individuals who were in utero exposed were communicating, were basically making it more likely those who are not in utero exposed as well were uptaking smoking. So it was not two independent populations, it was coupled. And by increasing the hazard rates of smoking among those who were in utero exposed, it was increasing rates of smoking among those who were not in utero exposed very highly as well. So there was a coupling between the two.
Was that a network effect?
Yes, there's a network effect. Yeah, it was communicating via the networks, and so I was looking for big differences. That one would have much higher rates of smoking, something like this, than the other, but I wasn't seeing it. It's because the other had really high rates of smoking because of contagion. So someone who was in utero exposed might be a smoker and thereby attract around them a whole network of people who are not in utero exposed but smoking as well. And so that tended to lessen the differences than we would have thought. So what I'm showing here is a case where we have no contagion and we have sort of 2.71 times higher hazard rate of initiation among those in utero exposed. And predictably, you see higher rates of smoking among those. This is looking at those who are adults and were born into the model. So there were two issues. One was sort of a data now, like framing clearly which subpopulations you're looking at and not being distorted by other confounding groups. And the second major issue was this issue of the two were coupled. And so the disparities were a lot less than I was expecting because of the coupling. Yeah, so that's a nice little example of using these models to trace down these impacts. And one of the reasons I was able to do this is because I was able to create these little experiments where I could turn off effects, enable effects, turn off effects, and sort of parcel out, okay, what was going on. Nice little example. It's too bad the class mixed it, but it's captured on video.
And can I ask just a kind of related question? Can you have two interacting networks of a single population?
Absolutely, no problem. Yeah, so you could have in fact, there's some example models where I've got that. Yeah, correct. Yeah, I've got that in one of the models. I'm pretty sure uploaded. I was trying to think about which one it was. I think it's under example models. Let's see. Yeah, so 2 types of networks. Thanks, Winchell. Much appreciated. Thanks, Annie. I'm looking here, which of these would have it? Two distinct networks per person. Use any logic 7. No reporting. I would use the one version 3 here. Yeah. I've got to upload another model here that might also have it. So actually, I should upload a folder.
Do you need a tea?
Got it. Thanks very much. Fruit also got. Okay. So I got another one that does this. I thought it might. Let's see. Figured. Okay, there it is. Okay, it's chlamydia, gonorrhea with network dynamics. It might have that as well. I'll upload it. It should be up there anyway. I just uploaded it. I'll check out if it has it. Okay. Okay, very good. I'll go load that in here. I think we're going to be getting going here in just a second. So, yeah. There you go. Okay. Okay. This, I can't remember if this ended up having, this may only have one type of network, but the other one definitely does. Nega, caters gonorrhea, keep seeking care. And do we have, yeah, it has both. It has a social network and a sexual network. That one I just uploaded, okay? Yeah. Okay, ladies and gentlemen, the answer is in a fully satisfying way, in a way that points to the power of dynamic models and dynamic modeling. And I will share the answer with you after I use the washroom. I've not yet had a chance to release myself from this room, so let me pardon me.